All right, folks, here we go. Trigonometric ratios. We're starting the trigonometry unit for geometry. So let's start with the do now, and we'll discuss our notes. This will probably be one of the longer videos because it's the first lesson in a brand new chapter, and I want to just make sure that we go over your notes as specifically as we can. So for you do now, it says given right triangle ABC, I'd like to point out that all of the triangles that we do in the trigonometry unit are going to be right triangles, okay? You can't really do trigonometry without right triangles, especially at your level. All right, so it says state the side of the triangle that's opposite of angle A. So what I want you guys to realize is anytime we use the word opposite, we're talking about across. Okay, so if I have angle A right here, the side that is across from it or opposite from angle A is going to be this side right here, which is my side BC. Okay, state the side that is opposite of angle B. So here's angle B. The one that's opposite of that is AC. We've discussed what an hypotenuse is earlier in the year, but it's the side that is always across from the right angle. So here's my right angle. This is my hypotenuse all the time. So state the hypotenuse is side AB. Okay, state the side of the triangle adjacent. Adjacent means next to. We discussed that this year as well. So next to is what adjacent means. So that's adjacent to angle A. The hypotenuse is always a hypotenuse. It can't be anything else. So here's angle A right here. The side that is attached to it or next to it is going to be this side right here. So that's going to be AC. Okay, and it even says, but not the hypotenuse. State the side of the triangle adjacent to angle B, but not the hypotenuse. So what's next to angle B, but that's not the hypotenuse, is going to be right here, which is going to be side BC. Okay. I'll discuss when we start going down here, but anytime I'm labeling, I always label the hypotenuse first, and then I do my opposite, and I save the adjacent for last. In my opinion, that's my personal preference. I find that to be the easiest. So when working with an acute triangle, an acute angle within a right triangle, keywords, right triangle. Okay, anytime we do trig, it's got to be a right triangle. We identify the sides of the triangle based on its relationships to that marked angle. So we always have to pay attention to what they're telling us, what angle we're utilizing, okay? So for here at the bottom, it says for each right triangle, label the appropriate size as adjacent, opposite, and hypotenuse with respect to the marked angle. Okay, so here is our marked angle, okay? We wanna put the, mark it as adjacent, opposite, or hypotenuse based on angle R. Okay, well, I always start with the hypotenuse. That's my personal preference because it never changes. It's always across from the right angle. So here's the right angle, across from it, here's my hypotenuse. Okay, then I like to move to the opposite. So here is my angle that I'm utilizing. This is my marked angle. So I'm gonna go across from it. That is my opposite side. So this is opposite. Therefore, this saves me. Last is the adjacent. Okay, that is the side that is next to angle R without it being the hypotenuse. Okay, so moving over to here, angle F is my marked angle. Okay, so again, I always start with the hypotenuse. It never ever changes. It's always across from the right angle. So here is my hypotenuse right here. Across from my angle F, here's my opposite. And this saves me, the last one is going to be my adjacent. All right. So far, those are the basics, super basics of trigonometry, is knowing how to label the sides, opposite, adjacent, hypotenuse. Okay. Now we're going to move forward with what we call SOHCAHTOA. Okay, so we have trigonometric ratios. Are ratios of the sides of a right triangle defined in connection with an acute angle. So it's just one of the marked angles. So when they say in connection to the acute angle, that just means, for example, this angle right here or this angle right here. You're never utilizing the right angle, okay? So there are three different trigonometric ratios. There's a sine ratio, a cosine ratio, and a tangent ratio. So we just like to do SOHCAHTOA, okay? If you can remember SOHCAHTOA and how to spell it, then you'll know all of your trigonometric ratios, okay? Sometimes I like to write it straight out and then create my ratios after, okay? So SOHCAHTOA. Okay, and then this is my sine is opposite over hypotenuse. My cosine is adjacent over hypotenuse, and my tangent is opposite over adjacent. Okay, there are three different trigonometric ratios. Okay, one of them is called sine. We can find that by doing the opposite side over the hypotenuse side. Cosine is found by doing the adjacent side over the hypotenuse side. Tangent is found by doing the opposite side over the adjacent side, okay? You always need to realize what angle they might be referring to. So here, they're asking me to find the sine of A, okay? So here is angle A. I'm gonna mark angle A so I can visually see which angle they're looking for me to do. Since I know I'm using angle A, I'm gonna go ahead and mark my opposite, adjacent, and hypotenuse. So here's my opposite, here's my hypotenuse. Again, I always save adjacent for last. It's my personal preference. But to me, it's always the one that I mess up if I try to do it first. So that's why. Sine, SOHCAHTOA. Sine is right here. Okay, so it's opposite over hypotenuse. So based on angle A, my opposite is at 3 over hypotenuse, which is a 5. So it's 3 over 5. So my sine of angle A is equal to 3 over 5. Just remember, a ratio is just a comparison of two different values set up as a fraction, essentially, okay? So when we're saying trigonometric ratios, they're just set up as fractions. So don't let that confuse you. I'm still talking about angle A here. I'm now going to do cosine. So it's my cosine is adjacent over hypotenuse. Adjacent is 4 over hypotenuse, which is 5. My last one is tangent, opposite over adjacent. Okay, I'm still utilizing angle A, so I have it labeled opposite over adjacent, 3 over 4. All right. They have the same exact triangle copied over here, but now we're just utilizing a different angle. I'm going to be focusing on angle B. So now my opposite, adjacent, and hypotenuse might change, although my hypotenuse never really changes. It's across from the right angle. So if it's the same triangle, my hypotenuse is going to be in the same spot. Okay, so there's my hypotenuse. My opposite is always across from there. So here's my opposite now. And here's my adjacent. Okay, so now I'm going to do the sine, cosine, and tangent, but now I'm utilizing angle B. So my opposite is 4, my hypotenuse is 5. Okay, I got that from up here, guys. Sine, SOHCAHTOA, sine, opposite over hypotenuse. Okay, this is not given to you on a test or a quiz. You do have to memorize that, or on your final, or in the Regents, but it is remembering SOHCAHTOA. You should be able to remember that. All right, moving on to cosine. Cosine is my C, adjacent over hypotenuse. Adjacent over hypotenuse. That's my husband singing in the background. You guys are welcome for that. Tangent is opposite over adjacent. Opposite over adjacent, that's a 4 over 3 here. Okay, so the ratios are going to change based on the angle that we're focusing on. Okay, notice we're not ever focusing on angle C because that's the right angle. It doesn't help us really at all. Okay, it's just kind of a rule. All right, here, it just says write each trigonometric ratio for each of the following. We're not solving anything. We're not doing anything different, okay? We're just focusing on the fact that we're utilizing angle 53. Sine of angle 53. So here's my 53 degrees. This is the angle that I'm focusing on. Okay, so here's our opposite. Here's my hypotenuse. Here's my adjacent. Okay, remember, opposite is always across from the angle that I'm using. Hypotenuse is always across from the right angle. My adjacent is the one that's left over. All right, so SOHCAHTOA. Remember how to spell it. Let me see. Okay. SOHCAHTOA. All right, so I'm looking for a sine. Sine is opposite over hypotenuse. Opposite is y over hypotenuse, which is 7. We're not looking to solve. We're not looking to get y equals. We're just looking to write in the ratio. Don't get confused with that. We will be solving tomorrow. Don't let this confuse you right now. Just because we see variables in there does not mean I'm solving. Okay, it says write the trigonometric ratio. Read the directions. Cosine is adjacent over hypotenuse. Here's my adjacent, which is x. Hypotenuse is 7. Okay. Let's use a different color. So I'm using my 30 degrees. Here's my 30 degrees right here. So this is going to be my opposite. Here's my hypotenuse. Here's my adjacent. Okay, sine, opposite over hypotenuse. Opposite over hypotenuse, which is z. Tangent. Here's my tangent, opposite over adjacent. Opposite over adjacent is 9.2 over x. Last one right here is going to be 67. So they have it marked for me already. Here's my opposite. Here's my hypotenuse. Here's my adjacent. All right. So sine, opposite over hypotenuse, so it's going to be 21.6 over z. Tangent is opposite, 21.6 over adjacent, which is x. Okay. Okay, find the approximate length of the leg opposite opposite the 80-degree angle to the nearest 10th. Okay, so that means we're looking, here's the opposite one. We're looking for the length of that, which is opposite. All right, so we're going to do, here's my opposite, here's my hypotenuse, here's my adjacent. Notice I have nothing labeled at adjacent. I have to pick which ratio is the best to use. Am I going to pick sine? Am I going to pick cosine? Am I going to pick tangent? Well, I have an x at my opposite, which is what I'm looking for, and I have a 24 with my hypotenuse. I have to pick out which trigonometric ratios, which one of these uses an opposite and a hypotenuse. Okay, I don't have anything for my adjacent, so I can't use my cosine, I can't use my tangent because they use adjacent. So I have to use my sine. So it's going to be sine of 80 degrees. Okay, the 80 degrees is the angle that we marked off, so that goes with the sine. If we use cosine, it would go with the cosine, so on and so forth. Okay, opposite over hypotenuse, so it's x over 24. Okay, I think that the easiest way to go ahead and solve this is by putting this over 1. You guys are very good at solving proportions. So we're going to just treat this as a proportion. We're going to cross multiply here. 1 times x is x. Cross multiply here. We're going to just type right into the calculator. 24 times sine 80 degrees. The trick with this is just making sure you're in the correct mode. Just give me a second. I have to open up my calculator. If I can find it anywhere. All right, so this is the calculator that I'm going to be utilizing. I think just mode. And we just want to make sure that we are in degree mode. So here it has highlighted radians. That's not going to give us the right answer. So highlight degrees. If you are on the regular calculator that we're used to at school, the TI-84, you're going to hit the same button. You're going to find the mode button and make sure that the degrees is highlighted. It should be, I believe, the second one down or the third one down. You'll see something that says radians or degrees. You always want to pick degrees. Okay, so what we're going to type into the calculator is exactly what we have over here. 24 times sine of 80. Okay, so it's 24 times sine 80. Okay, it'll automatically put it in degrees for us, and realize we don't know what radians are until you're in algebra 2. Okay, so just degrees is what you guys are focusing on. And it tells us to round to the nearest tenth. So that's going to be x equals 24 times.
Rich chocolate candy, creamy caramel.
That was the calculator doing an ad, sorry. Sine of 80, which is what we typed into the calculator. I don't remember what the answer turned out to be. 23.6. 23.63 dot dot dot. It told me round to the nearest tenth. This 3 tells me to keep that 6 the same, so it's 23.6. Okay, and this is what we're going to focus on a lot tomorrow. Okay, the most important thing we want you guys to take away from today's lesson is knowing how to write these ratios appropriately. Okay, the hardest part of this one, which is what we really want you to focus on today, is being able to pick out the two pieces and pick out the appropriate ratio to use. Am I going to use sine, cosine, and tangent based on the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent? Okay. All right. So for your independent practice, you just have 2 questions here, just because the video is getting a little bit long. So I want to be able to upload it and not have it take an hour. And indicate which leg is adjacent, which is opposite to the given angle. Okay, so indicate which leg is adjacent and which is opposite. We know that this one is the hypotenuse. Okay, so based on here, I want you to label this side over here and this side over here. One of those is going to be opposite, one of those is going to be adjacent. They want you to find the length of the smaller leg of the right triangle. Okay, obviously this is the smaller leg, so this is where we're going to put the X. Okay, so we're going to make sure that we pick the right, once you have it labeled, opposite and adjacent and hypotenuse. Based on what you're given, you have to choose the correct one. Is it going to be sine, cosine, and tangent? Set it up. Okay, so this is going to be sine of 30 or cosine of 30, tangent of 30 is equal to whatever that ratio is going to be. And then you're going to use the same exact method over here. Just put this over 1, so it's a fraction 2 that just doesn't change the value of it, and then solve the proportion. Okay, we'll do our best to try to help you guys out as much as we can, but I want you guys to at least try. I don't care if you get it wrong. There's no problem with that. All right, just make sure you guys show us your effort. Okay, utilize SOHCAHTOA right here. Have a good day, guys.